All right, geometry students, welcome back to our unit going inside triangles. Today we're going to learn about medians and altitudes and have lots of fun because this is the part where vocabulary gets a little crazy. So what are we going to cover in the lesson for today, or uncover, I should say? We're going to uncover stuff about medians and altitudes. We're going to go over what is a median, what is an altitude, and check out these two words, a centroid and an orthocenter. Awesome! We're going to do some review from algebra about finding slope and perpendicular slope. We're going to be able to identify the difference between a median and an altitude and learn some interesting stuff about lengths with medians when they intersect. And how do we find the orthocenter? That's not your dentist, but how do we find an orthocenter of a triangle? We're going to cover all this beautiful stuff. And we're going to begin, as we normally do, with notes. Yeah! So let's do a quick review what we already know about what goes on inside triangles. We already know that when perpendicular bisectors meet, they meet at the circumcenter. And we know that when angle bisectors meet, they meet at an incenter. And we know what a perpendicular bisector is and what an angle bisector is. Okay, so this is what we've already covered, and hopefully you know that. So let's learn new stuff. So there's more to learn. The first thing that there's more to learn about is medians. So we're going to learn about medians. This is from the textbook here. The medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex and midpoint of the opposite side. What? So let's translate English into English and learn about what a median is. What a median is, it goes from the vertex of a triangle to the midpoint of the opposite side. That is a median. Okay, so from the vertex to the midpoint of the opposite side, vertex to the midpoint, vertex to the midpoint. That is a median. Make sure you know that. Where they meet, the point of concurrency is called the centroid. Isn't that an awesome name? That's such a cool word. I love it. Now, there's something cool about the centroid. Besides the fact that that's where you balance a triangle, like you can balance a triangle on your finger if you use it on the centroid. But aside from that, it cuts medians into thirds, right? Into 2/3 and 1/3. And so you have 2/3 distance here, 1/3 distance here. 2/3 distance here, 1/3 distance here. 2/3 distance here, 1/3 distance here. And that's what this is saying, right? When you look at all that crazy mathematical stuff, okay, so when we talk about what happens with a centroid, it cuts medians into 2/3 and 1/3 pieces, okay? So again, 2/3 there, 1/3 there. Okay, that's what a centroid does. It cuts it 2/3 there, 1/3 there. That is a very, very important note. Now, with that is going to bring some algebra review. I'll show you this once, and then we'll go over easier ways to handle this later. Algebra review, if we have a crazy equation like this, we're going to solve for x. How do we do this? If you remember, there's a fast way where you multiply both sides by the reciprocal. That's an easier, well, that's a one-way step of doing that. So how do you undo a fraction is you multiply both sides by the reciprocal. So we look at this, you know, what's going on with the x? There's a 2/3 there. It's being multiplied by 2/3. So we can multiply both sides by the reciprocal, 3/2. So you got to remember what reciprocal means, right? Reciprocal means flippity-dip. Okay, so we got to remember that. Reciprocal means a little flip action going on there. And we're going to multiply both sides by the reciprocal, and that's how we undo that. So in this particular example, to solve for x, we multiply both sides by 3/2. We have x equaling 3/2 times 14, which turns out to be 21. No matter how you do it, you can divide 14 by 2 to get 7. 7 times 3 is 21. Or multiply 3 times 14 to get 42. 42 divided by 2 is 21. Either way, you're going to get 21. Okay, so that's a bit of algebra review to help us since we're dealing with thirds. Okay, so for dealing with thirds and all that stuff with medians, we're going to learn that. We'll do more practice later. Back to vocabulary. Median, from the vertex to the midpoint. Next, we're going to learn about altitudes. Yay! So what is an altitude? It's basically the height of a triangle. The altitude is basically where you drop a perpendicular from the vertex to the opposite side. That's what I normally say. Drop a perpendicular. So the lines that contain the altitudes meet at a certain place. But if you look at a triangle in this way, you drop from the vertex, boop, perpendicular. That's the altitude. Okay, and you can turn the triangle however you want, right? From the vertex, boop, perpendicular. That's the altitude. And again, turn the triangle whichever way you want. Vertex, boop, perpendicular. That's the altitude. Okay, so you don't want to let gravity mess with you. If it's if what you're looking at is hard to fathom, feel free to rotate your paper around. Anyway, the altitude is the height. Okay, so it's perpendicular from the vertex to the opposite side. So when we drop a perpendicular from the vertex, we have an altitude. Now the altitudes meet. They have a point of concurrency. They meet at a place called the orthocenter. Okay, so that's the deal with altitudes. They meet at a place called the orthocenter. Okay, so this is your notes. If you need help with remembering any of that stuff, hit pause and rewind and copy. Okay, so Miss Book, if you remember, she was the awesome colleague of mine that helped us with Purple Bear Circus and Angry Birds Inside. We were talking about perpendicular bisectors meeting at a circumcenter and angle bisectors meeting at an incenter. Well, Ms. Book also has a couple other helpful hints with a Mexican centipede to help us remember that the medians meet at the centroid and that altitudes meet at an orthocenter. Okay, so medians meet at a centroid, altitudes meet at an orthocenter. Okay, so medians, centroid, altitude, orthocenter. Okay, and then Mexican centipede we'll use, and attack otters we'll use. That'll hopefully help you remember. There's some neat facts and stuff. It is the center of gravity. The centroid is the center of gravity, point of balance for a triangle. And again, there's that 1/3 and 2/3 fact. Okay, so for the students in my class, I have this available to you to remember. If you're not in my class, well, I'm sorry about that. Take a look at that. Pause, freeze frame, just to help you remember some stuff. That's a helpful hint. Let's get to work. Let's do some examples. Let's learn these notes. We're going to identify medians and altitudes. Okay, so back to that vocabulary piece that we were learning about. So here's an example. For the triangle PQS, is PR the median and altitude or neither? Explain. So we got to look at this triangle. Well, there's triangle PQS. PQS is the triangle here. Well, what's the deal with PR? PR is going from a vertex and it's being dropped to a perpendicular. I just gave it away, right? It's being dropped to a perpendicular from a vertex. Okay, dropped to a perpendicular from the vertex. That is the height, which is also known as altitude. Altitude would be the correct response. That's some vocabulary help right there. The whole big thing is vocabulary. So in this case, that's the altitude. Okay. Okay. Next example about identifying medians and altitudes. Well, here's a triangle ABC. Is AD a median and altitude or neither? Explain. So here's our big triangle ABC. A, B, C. Big triangle, right? The question is about AD, segment AD. So segment AD. What's going on with segment AD? What's happening? Well, clearly it's going from a vertex. That's helpful, right? So it's going from a vertex. So that's going to, it's going to be one of the two things that we learn. Remember, altitudes are from the vertex. Medians are also from the vertex. So it's going to be one of the two things we learn because it's going from the vertex. But where is it going to? Right? So AD is going from the vertex and it's going to here. Now, where is here? Notice something interesting. Here happens to be a midpoint. And how do we know? Did you guess? How do we know it's a midpoint? Because each side is congruent. Okay, so each side of D is congruent, so D is a midpoint. So we got to know that. So it's going from a vertex to a midpoint that has a name, that has vocabulary name, that is a median. Okay, so we have to know the difference between altitudes and medians and everything else we've learned. Mid-segments, angle bisectors, perpendicular bisectors, so on and so forth. So lots of neat things, by the way. So that's how we identify a median and altitude. By the way, pop quiz. Pop quiz. You see E? You see D? What do we call ED? Huh? What do we call ED? ED is called a mid-segment, connecting midpoints. Just so you know, we got to keep review strong. Anyway, moving on. Next question. Now what we're going to do is work on finding the length of a median. Remember we talked about thirds. Okay, so we had our quick review of algebra stuff. You know, how do we solve equations with thirds? Let's see if we can do that. So we have this diagram here to the right. It is telling us that XA is 8. So from X to A is 8 units. What is the length of B? So what's happening in this diagram? What are we looking at? Hopefully you know that what are we looking at is medians, right? I want you to be able to tell that. We are looking at medians. How do we know? Because they're all going from vertices to midpoints. From vertices to midpoints. And from vertices to midpoints. So we're dealing with medians. And medians intersect at centroids. Okay, so we're looking at medians. Medians meet at centroids. Remember, Mexican centipede. Okay, so medians meet at centroids. And the cool thing about medians is that they cut into 2/3 and 1/3. Okay, so remember how that works in the note. 2/3 and 1/3, 2/3 and 1/3. So we've got to remember that, 2/3 and 1/3. So in this particular example, we're looking at the right, XA is 8. So from X to A is 8. That means 8 is 2/3 of the whole big thing. So this is what we're talking about, right? XA is 8. 8 is 2/3 of the whole big thing. So 8 is 2/3 of the whole big thing, of XB. Okay? Now, we can use an equation for that, right? We could say 8 equals 2/3 of XB, and then use algebra, but there's an easier way. If 8 is 2/3, okay, so we got to think now. If 8 is 2/3, here's my question for you. Put your thinking caps on. What is 1/3? Okay, that's the question. If 8 is 2/3, how much is 1/3? Okay, so 2 pieces make 8. How much is 1 piece? That means 1/3. 2 pieces make 8. How much is 1 piece? 1 piece is 4. Okay, so if 2 pieces make 8, then 1 piece must be 4. Okay, does that make sense? I hope it makes sense. That's thinking cap. You want to use algebra, go ahead, because you can still do it. But I'm trying to help you with thinking cap. If 2 pieces make 8, 1 piece must be 4. Okay? So if we have all of this cut up here as 8, that means we're dealing with 1 piece, 2 pieces, 3 pieces. Each piece is 4. Okay, that's the whole concept of thirds. We got to know what thirds are. 3 equal pieces, right? That's what thirds are. So when we look at XB being cut into thirds, 8 is 2 of them. The last one must be 1/3, right? So if 8 is 2/3, 1/3 must be 4. We got to know all of this stuff. Now we can answer the question, right? So if 8 is 2/3, what's 1/3? If 2 pieces make 8, 1 piece must be 4. So now we know all 3 pieces are clearly going to be 12, but that's not the point. The point is making sure that you can follow thinking cap, right? Follow logic with some math. You know, sprinkle in logic with mathematics. You can get that. So anyway, 1 piece must be 4. So that means we're dealing with 3 pieces of 4. That's what thirds means, right? We got to know what thirds means. So we're dealing with 3 pieces that must be 4. So the whole big deal, the whole distance from X to B is going to be 4, 4, 4. 12, right? It's going to be 12. So the distance from x to b is 12. Now, can you use algebra? Absolutely. I will never, ever prevent you from using algebra. How do we solve for xb here? Remember the trick. Multiply both sides by the reciprocal. Okay? And you can do that. You can multiply both sides by the reciprocal. And when you do, xb is going to be 24 divided by 2, or 4 times 3. Either way is 12. Right? It doesn't matter how you look at it. xb is going to be 12. Okay? So when we're dealing with thirds, there's some fun ways to do that. Okay, so let's do the next example as well, and hopefully you can see the concept of thirds coming into play. So then in the diagram, and as you can see, are we working with medians? Yes, we are. We're working with medians. Okay, we are working with medians, so we have a centroid. ZA is 9. So from Z to A is 9. What is the length of ZC? So 9 is 2/3, okay? 2/3 of the median. Because remember, it's cut into thirds, right? So 9 is 2/3 of the median. That means each piece, each third, okay? So each piece must be, how much, right? 9 is 2 pieces, so cut it 9 in half, 4.5. Don't be afraid of decimals. They exist, right? Decimals are numbers. They have feelings. Don't ignore them. They totally exist. So each piece must be 4.5, okay? So if 9 is 2 pieces, then 1 piece is 4.5. That means this whole median from Z to C, the whole median is cut into 3 equal pieces that are 4.5 each. 4.5, 4.5, and 4.5. Okay? So we have 9 4 is 13.5, right? So what is the length of ZC? 13.5. That would be the length. You can think. Or, feel free. 9 equals, right, 2/3 of the median, right? 9 equals 2/3 of the median. I'll never stop you from using algebra. Never, never, never. So 3 times 9 is 27. 27 divided by 2. 27 divided by 2, guess what? 13.5. Either way, you're going to get the same response. You want to use algebra? You can. If you want to think, which I prefer you think, it's going to make your life easier. Anyway, that's thirds. Whee! So much fun with medians. Okay, let's take a break. Shall we? Yes. Review. We're going to jump into finding the orthocenter. Remember what orthocenters are? Orthocenters are where altitudes meet. Okay, so you got to remember, orthocenters are where altitudes meet. And what is an altitude? It's when we drop a perpendicular. Perpendicular is going to come back in a second, but we need to do some review. So I have this diagram with a bunch of things going on. We got to learn about slope. No, Mr. Katz, not slope. Yes, slope. What is slope? Well, we got to remember, slope is a ratio of change in the dependent variable to the change in the independent variable. The ratio of change in the dependent variable to the change in the independent variable. What? Oh, change of y over the change of x. Oh, okay. Change of y or the change of x. Oh, is that one formula, right? Yeah. Slope equals y2 minus y1 over x2 minus y1. Slope is, right? That's what this means. Rise over run. So all these things about review for slope. But my main question is, can you count? Rise over run is very helpful because it's about counting. So we have in this diagram 4 lines. Hopefully you see them. We have line A, we have line B, we have line C, and line D. What we're going to do is find the slope of each of those lines. This is a review. And the question is, can you count? Okay? So if you look at the slope of line A, here's line A, right? You see line A. We have 2 ordered pairs there. Do you want to use the slope formula? You can. I'm not going to prevent you from using the slope formula, but can you count? I want you to count. Rise over run. How far up and down to how far left and right? So from these 2 ordered pairs is the slope of line A. So from this ordered pair, we're going up a certain number of units. We're going up 1, 2, 3, 4 units. So we're going up 4 units. And we went up 4 units, and now where are we going? 1, 2, 3 units to the right. So in line A, from ordered pair to ordered pair, we're going up 4 and then right 3. Now, funny thing about up is positive. Funny thing about right is positive. So the slope of A is 4 over 3, right? Review. How about the slope of B? So here's line B, okay, and we've got two ordered pairs here, and we're going to count rise over run. Up, down, left, right, doesn't matter. Rise over run from point to point. And so we're going to go, I'll start up here. All right, so I'm going to start at the top order pair, and I'm going to go up or down. Clearly, I'm going to have to go down. 1, 2, 3, 4 units. So for a slope of B, I'm going down 4 units. Okay, so I went down 4 units. Now I'm going 1, 2, 3, 4, 5 units to the right. Okay, so for line B, I went down 4 units and then 5 units to the right. Now, down happens to be negative. Right happens to be positive. So the slope of line B is negative 4/5. Okay, that's our slope of line B. Review. Slope of C, here's what's interesting. If you look at slope C, rise over run. If I'm going from point to point in line C, am I going up or down at all? No, I'm not going up or down at all. I'm not going anywhere. So I'm actually going nowhere, right? So I'm going up 0, and then right irrelevant, or left. Right, left, it doesn't matter, because 0 divided by anything is 0. Right? Once you have 0 in the numerator, 0 over anything is 0. It doesn't matter. And then the slope of line D, okay, so if I look at line D down here, I'm going up or down forever, right? But I can go up, let's say 2, even if you look at it that way, let's say up 2. Am I going to the left or right at all? No, I'm not. Okay, so for line D, I'm not going left or right, so I have no run. It's 0 in the bottom, which means it's undefined because you can't divide by 0. So the slope of line C is 0. The slope of line D is undefined. We have to know the difference between that, but more importantly is can you count, okay, to find slope. Now, why? Why is it important to do that? Because, remember, we're dealing with orthocenter, which deals with altitudes, and altitudes deals with perpendicular, and perpendicular has a very huge impact with slope. Okay, so we have slope here, and perpendicular is totally related to slope. Okay, so more orthocenter review. Slopes of perpendicular lines are a thing. Okay, I'm not even going to read that because I'm running out of time, but slopes of perpendicular lines are a thing. They're opposite reciprocal of one another, slopes are, right? Because two non-vertical lines are perpendicular. Their product of their slope is -1. The product of two perpendicular lines have a slope of -1, right? So, and another neat thing, horizontal line and vertical lines are always perpendicular. So what does this mean? This means this. If there's a slope of 3/5, then the perpendicular slope is the opposite reciprocal, -5/3. If the slope is -7, then the perpendicular slope, opposite reciprocal, is going to be positive. What the heck is the reciprocal of 7? 1/7. Because remember, 7 is the same thing as 7 ones, 7/1. Okay, so the perpendicular slope, the reciprocal, is 1/7. Okay, so that's review. You got to remember that from algebra. So here's a crazy diagram, and now what we're going to do is start sketching some stuff. Okay. So here's the deal. We're going to sketch a line that's perpendicular to line A. So here's line A. We're going to sketch any line anywhere that's perpendicular to this line. How are we going to do that? Well, first we need the slope of line A, right? So the slope of line A, rise or run, 1, 2, 3, 4, 1, 2, 3 is 4/3. Now, what's going to be perpendicular to that slope? Perpendicular to that slope is going to be -3/4. Okay, the opposite reciprocal. So this perpendicular slope is -3/4. So what does that have to do with sketching a line? That means if we take any point on line A and we count the perpendicular slope of -3/4, then we have a perpendicular line. So here's an example. Let's use this 2, 3 here. We're going to use this point. We're going to count the perpendicular slope of -3/4. So from this point, we're going to count down 3, 1, 2, 3, right 4, 1, 2, 3, 4. So from our given point to the amount that we're counting in slope, we will now have a perpendicular line. That line is totally perpendicular to A. These are perpendicular now. Okay, that's by definition. Okay, so we have the perpendicular slope. What about perpendicular to line B? So we look at line B, and we find the slope. So what the heck is the slope of line B? Well, from point to point, down 1, 2, 3, 4, right 1, 2, 3, 4, 5. Slope of B is -4 over 5. So perpendicular to that, perpendicular to a slope of -4 over 5 is going to be positive 5 over 4. That's right. That's right. Positive 5 over 4. This is a positive number. The slope would be a negative number. This is a negative number. Perpendicular is going to be a positive number. Okay? So we're going to count a slope of 5 over 4 from any one of these points. So let me use the bottom point here. I'm going to count a slope. Count, rise or run from this point. Positive 5 over 4. So up, 1, 2, 3, 4, 5. And then right. I don't think I counted that right. 1, 2, 3, 4, 5. And then right. 1, 2, 3, 4. So from 4, -2 to my new point, because I counted slope, that is perpendicular to line B. Okay, so we have to be able to know how to do that. And a sketching line perpendicular to lines C and D. Well, here's line C. C is a horizontal line. What's perpendicular to horizontal? Perpendicular to horizontal is vertical. So any vertical line will be perpendicular to line C. So I'll draw a line down there. That's perpendicular to line C. And then line D is vertical. Any line horizontal would be perpendicular to line D. So I'll draw a line right here, and that is perpendicular to D. Okay, so that's review for slope, and that's going to help us with Orthocenter. Okay? If this was confusing, I know some of us have struggled with basic algebra, so this is a great opportunity to pause and rewind. Make sure you understand this is crazy. Anyway, how are we going to use that? Well, let's find the orthocenter of a triangle. Orthocenter means we're dealing with altitudes. And altitudes means we are dropping perpendiculars. Okay, so we're going to be dropping perpendiculars from vertices. So triangle ABC has vertices here, here, and here. There they are. What are the coordinates of the orthocenter of ABC? So we need to find altitudes. That means we're going from vertices. Now, look at the sides of the triangle. Are there any easy picking sides? I think the first thing to do would be look for horizontal or vertical sides. And check this out. AC is horizontal. Okay, if we noticed, AC is horizontal. That means perpendicular to that is going to be vertical. So perpendicular horizontal is vertical. But remember, altitudes have to go from the vertex. So if AC is the side, what's the vertex? The vertex is going to be B. That means from B, we have to draw a vertical line. Okay, so from B, we're going to draw a vertical line. And from here's B, bloop, 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 vertical line, perpendicular, altitude. Okay, perpendicular, altitude. Now, how do we do? What are we going to do to find the other ones? Well, let's take a look at vertex A. Okay, if we look at vertex A, that means we're looking at side BC. So we have to figure out what is the slope of BC. The slope of BC, remember we got to count, rise over run. So I'm going to go up 1, 2, 3, 4, and then left 1, 2, 3, 4. Oh, up 4 and left 4. That's positive 4 over negative 4. You know what that is? You know what positive 4 or negative 4 equals? Negative 1. Boop. So the slope of BC is negative 1. But we're dealing with dropping a perpendicular. So what would be perpendicular to negative 1? If you flip negative 1 and change its side, the opposite reciprocal of negative 1 is positive 1. The perpendicular slope is positive 1. So that means from A, from that vertex, we're going to count a slope. How do we count a slope of 1? Up 1, right 1. That is a slope of 1. Up 1, right 1. Okay, Algebra 1 review. So from vertex A, we're going to be counting up 1, right 1. So from vertex A, up 1, right 1. Up 1, right 1. Up 1, right 1. And there is our altitude for A. Now, if you needed to rotate your triangle to do that easier, fine, go ahead. You can do that. Now, we're actually done, do you know? Because we're looking for the coordinates of the orthocenter, where the altitudes intersect. Do we need the third altitude? No, we don't, but we can still do it anyway. So let's take a look at vertex C. Vertex C is going to intersect side AB. Now, what's the slope of side AB? The slope of side AB is 1, 2, 3, 4 over 1. The slope is 4. That means perpendicular to 4, negative 1/4. Look how fast I'm going now. That means from vertex C, we count a slope of negative 1/4. Now, how do we do that? If we go down 1 and right 4, we're not going to be in the triangle. If we go down 1 and right 4, we're not going to be in the triangle. So we have to be able to go another way. We can also go up 1 and left 4. That's the same slope. Up 1 and left 4 is the same slope. So from vertex C, check it out. We're going to go up 1 and left, 1, 2, 3, money, right? And there's our altitude from C. So the whole deal is, didn't even cross that. Can you count? And now we can clearly see that the orthocenter is right here. There is our orthocenter. And the question is, where in the world is that? That is at the coordinates 2, 4. Okay, so that's at the coordinates 2, 4. Okay, so that slope exercise is extremely important, ladies and gentlemen. If this was confusing, pause, rewind. But in the meantime, let's do another one. So here we go. Here's triangle DEF has vertices D at 1, 2. And let's graph that. D is at 1, 2. E is at 1, 6. Let me count. 1, 2, 3, 4, 5, 6. And then F is at 4, 2. 1, 2, 3, 4, 1, 2. Yeah, make sure I did that. So I have a triangle here. Boop, bloop, bloop. So, what are the coordinates of the orthocenter? And again, the orthocenter is altitudes, and altitudes means dropping a perpendicular. Altitudes. Okay, so it means we're going to drop a perpendicular from the vertices. Now, here's what's interesting about this particular example. We're done. We're actually done. We're looking at the orthocenter. Because check this out. Our side here is a vertical side. Okay? It's a vertical side. And this side down here is a horizontal side. So if I'm looking at my vertex right here at point, which one is that? That's point E. If I'm looking at my vertex at point E, it is perpendicular down here, right? So it's perpendicular right there. I've dropped the perpendicular without even having to do work. And then if I look at point F over here, I can even rotate my triangle. If I drop a perpendicular, there it is. Holy cow, they meet at that corner. They meet at D. Okay, so the intersection of the two altitudes is actually there. The orthocenter, we're looking at it, is at D. Okay, now, just for good measure, it doesn't matter what the altitude is going to be from D, so we have found our orthocenters right there. Okay, so not all of them require that crazy detail. They meet at D. So what are the coordinates of the orthocenter? 1, 2. Not all of them require the crazy detail that we did in the previous example. We're counting slope and finding perpendicular. Yes, we need to know how to do that, but sometimes looking right at the orthocenter. Okay, isn't that neat? So hopefully we know that. If anything was confusing, pause, rewind. Fun stuff. All built on vocabulary. So let's take a quick quiz, shall we? Let's. In the triangle shown below, which altitude length can be found without using the distance formula, and what is the length? Okay, so we have a triangle here, and we're looking to see which altitude length can be found without using the distance formula. So here's choice A. The altitude from N to LM. Here's N, and here's LM. Can we find the altitude? Well, I don't know. Can we drop a perpendicular? You know what? We can. Take a look at N. Here I am. Okay. Take a look at N. Can we drop a perpendicular from there? Yes, we can. the perpendicular is right along here. What? Whoa, and fortunately, LM is horizontal. So that's totally helpful. So we have a perpendicular. LM is horizontal. N is on a vertical line from there. So guess what? We have seriously just found an altitude without using the distance formula. But then it says 6 units. Are we sure the altitude is 6 units? Let's count. 1, 2, 3, 4, 5. Winner, winner, chicken dinner. Boom! Choice A. So, I think I warned you. This was a crazy lesson, okay? But hopefully it was helpful, I think. I had fun. Did you have fun? So, remember we had to learn all about this stuff. Vocabulary is where your eyes go. And then we just got to know some math. The whole rest is practice, practice, practice. So that's it for me, ladies and gentlemen. I will see you on the next lesson.